Greetings and good morning. I'm going to re-record the lecture that I just gave, mainly because of a number of challenges that I was having during it, and also because of the background noise. Unfortunately, on Friday mornings, we have the landscaping done, so I guess we're going to have to deal with this at least for now, while the landscapers continue to mow the lawn. Anyway, what I'd like to do today is we'll talk about water supply design. Now, we're going to look at the design of a water treatment system. We're going to focus on Brighton. Brighton is about 40 miles east of East Lansing. It's located on the I-96, I-23 corridor. And there are really two potential sources of water for Brighton, and that's the Huron River and groundwater. And this is just expanding on looking at Brighton. You can see this is the city of Brighton. And now we're moving in. You can see it's a well-developed, there isn't a lot of open space. It's surrounded by a number of townships, Brighton Township, Genoa Township, and one of the things we need to think about in designing the system is who are we serving? Are we just serving the city of Brighton? Are we serving people living in the surrounding townships? And as I mentioned, the two major sources would be the Huron River, which is to the south of Brighton, and groundwater. So let's look at some of the factors that affect water usage. Major factor is climate. You'll see in the table on the next page that water consumption in the northern states and the Midwest is significantly less than in the Southwest. Industrial, commercial activity will play a significant role. Industry tends to use a significant amount of water, especially on a per capita or per person basis. Another aspect is meterage. So whether the homes or users are metered, whether their water usage is metered, that plays a significant role, and can actually putting meters on a home can actually reduce water usage by up to about 40%. System management. Are there leaks in the plumbing or the piping network? Are pipes being replaced? What's the condition of the piping system that is distributing water? The standard of living plays a very significant role. Socioeconomic status. People that are wealthier tend to use more water. They water their lawns more than people that are on a lower economic status. Agriculture. Agriculture is a major user of water. So if you're supplying water for agricultural uses, then you're going to see a much higher water usage. Okay? This is all on a per capita basis. If we're looking at the entire system, then we need to think about the population that is served, what industries are present. We also need to think of the service area. So who are we serving? Are we just, for instance, serving the city of Brighton, or are we serving the surrounding townships? As I mentioned, this is actually a table from your textbook. It's table 2-6. I added water usage in gallons, and you can see that in the North and Midwest, typically it's about, you can see it's 122, so it's about 120 gallons per person per day, and it's roughly twice that if we look at the Southwest. So looking at Brighton and water demand, you can see here that the population in Brighton was increasing significantly to about 2010, and then it has been relatively stable since then. Part of that is because there's been significant development. There isn't much more land to develop. You can also see that typically only about 20% of the water that we produce and distribute is used for drinking. Yet our standards are set for drinking water, and we are producing water, for instance, for flushing toilets that meets the same quality that we do for drinking. Some cities are moving to a dual plumbing system where they don't treat the water for toilet flushing to the extent, or they're actually recycling water within a facility to try and reduce water consumption. But all of our water, typically in the US, is treated for drinking water standards. And you can see here, as I mentioned, leakage typically is about 10%. Poorly managed system can be upwards of 30 to 40% losses. The demand for water is highly variable. It's variable seasonally. It's variable on a diurnal level. This really focuses on those diurnal levels. So we talk about an average daily flow. We also talk about a max daily and a peak hourly flow. Your design of your unit operations will be based on the maximum daily flow. The plumbing system, all of your piping network, your pumping systems will be designed based on your peak hourly flow. Fire demand typically is maintained by storage. If you don't have storage, then you include that fire demand in the peak hourly flow rate. You can use these two multipliers to calculate the max daily and the peak hourly, or you can use the graph in your text, which actually has a calculator embedded in it, and that allows you to more accurately calculate that maximum daily and peak hourly flow rates. Moving to the sources of drinking water, typically we have really two different sources. We have a groundwater source and we have a surface water source. Groundwater sources can be shallow wells. Typically these are less than about 100 feet deep. Your deep wells often 300, 400, maybe even be 500 feet deep. When we talk about surface waters, we can talk about rivers, lakes, reservoirs. So for instance, the city of Ann Arbor uses a mixture of of deep wells, groundwater, and water from the Huron River. The city of Grand Rapids pumps water from Lake Huron to the city, and it's treated. They did use in Grand Rapids about 50 years ago, they did use Grand River water. However, because of the poor quality of the Grand River water and lack of sufficient water, they switched to pumping water from Lake Michigan. So when we talk about water sources, we can talk, as I mentioned, surface water, groundwater. One of the things to recognize is in the US, the population served by surface water systems is actually about 1.5 times that served by groundwater systems. On the other hand, the number of groundwater systems in the US is actually about 10 times the number of surface water systems. The reason is that your larger population areas, your larger cities, tend to be served by surface water systems, whereas your smaller population areas, your more rural areas, are served by groundwater. And that has to do with the fact that typically You can produce sufficient water for a large city like Los Angeles, like New York City, like Chicago, from groundwater. So we use surface water. Number of things to think about. Your groundwater supply tends to have less fluctuations in quality and quantity than your surface water systems. Your groundwater system provides natural storage. So the aquifer itself is providing storage. You don't have to build a reservoir to store that water. And it also provides protection. So the water that actually moves through the ground is naturally filtered, so it tends to be less contaminated than your surface water. Some of the considerations that we need to think about has to be our demand. So can we produce sufficient water from either a groundwater or a surface water source? We want to prevent overpumping. So we want to avoid this. That results in subsidence, which is extremely problematic. It also is a loss of storage in your aquifer system. And then we need to think about allowable yield. So here we're really talking about riparian rights versus appropriation law. So we're really into the legal realm here. And this question during class about basically resolving these issues. And typically, if there is a dispute over water usage, then that is decided in the court system. Major problems, for instance, major disputes in California between Northern California and Southern California. Southern California gets much of its water from Northern California, and that potentially impacts the Northern California in terms of their growth, ability to grow, ability to access water. So in that case, it really turns to the court system. So if we look at groundwater versus surface water, as I mentioned, typically you've got a more constant composition, whereas surface water is more variable. Temperature is more constant. So for instance, in Flint, when they were using the Flint river water, the variability in temperature ranged from about 2 degrees C all the way up to almost 25 degrees C in that period of time when they were using the Flint River water. Lake Huron water, they have a deep intake, so the water temperature tends to be more constant. So with a large lake, like Lake Michigan, Lake Huron, the intakes tend to be deep, so you can maintain a more constant temperature even though you're using a surface water, and that plays a significant role in operation and the efficiency of your processes, because temperature plays a role or affects efficacy of the process. Often with groundwater, especially true in Michigan, you've got a high mineral content, high calcium, levels of calcium and magnesium. It's very hard water that impacts ability of soap to lather affects scaling in your piping and your plumbing network. And this tends to be lower in a surface water. Typically we have low color. That water is naturally filtered, so we have less color in a groundwater system where we have a higher color, often in a surface water system. Similarly, we have less taste and odor issues in a groundwater system and more taste and odor issues in a surface water system. That's especially true in late summer if you have algae blooms, because the algae give off various chemicals and you get kind of this musty odor from the surface water. On the other hand, if you have a high mineral content, you can have a mineral taste to that water. We typically have low dissolved oxygen in our groundwaters and a higher dissolved oxygen in our surface waters. Because of the microbial activity, we often have a higher level of CO2 in our groundwaters, but a lower level of CO2 in our surface waters. Because of microbial activity, hydrogen sulfide may be a problem. Parts of Michigan, this is a major problem. The groundwater has kind of a rotten egg smell from that hydrogen sulfide. It's naturally occurring. Basically, you've got a reduced state, and sulfate is reduced to sulfide, so you have hydrogen sulfide production. That tends not to be a case in surface waters. And lastly, typically you will have a higher organic matter content in your surface waters and a lower organic matter content. The N stands for naturally, so this is naturally occurring organic matter in your groundwaters. So when considering surface waters versus groundwaters, and we're looking back at the Huron River, so we're back thinking of Brighton. So what are some of the issues that we need to think about? Again, flow rate. How much water do we need to produce? How much water can the wells produce? So, productivity of the wells. We need to think of contamination levels. One of the challenges that Ann Arbor, for instance, is dealing with in the Huron River is PFAS in the in the surface water system. They've actually been dealing with 1,4-dioxane in the groundwater system. So those contamination issues play a significant role in thinking about, well, which system do I use? Location. So location of the surface water. How far do I have to pump water? Variability we mentioned. So variability both in the groundwater and the surface water, and we're talking both in composition and flow rate. We also want to think about opportunity costs. And as I mentioned in class, we'll talk more about that. What does that mean when we talk about opportunity costs? And we need to talk about water law. Okay, so I will stop here. We will pick this up on Tuesday. And remember, no class on Monday. because of Labor Day, and I look forward to seeing you on Tuesday.